Morning, everybody. From Berkeley, California, this is the Data Colada Seminar Series. And I would like to welcome today's speaker, Tom Meyvis from New York University, and our set of wonderful panelists, Liz Dunn, Mike Norton, Rebecca Ratner, Oleg Erminsky, Hee-Young Yoon, and Gal Zauberman. In addition, we're joined here with Joe Simmons and Yuri Simonson. Tom will be speaking for the next hour or so. During that time, as you can see on your screen, you'll be able to send Q&A questions or comments to our panelists who will be able to read them. Tom presumably too busy to read them themselves, but don't worry, our panelists are all comfortable speaking out loud and interrupting Tom with questions or comments. And even if they don't, you should know that your comments or questions are going to be saved, and Tom will get a chance to read them and potentially respond to them even after the session is over. Finally, the last part is that all of this is being recorded, and once we get everything sorted and it's all over and we figure out the technology, it'll be posted on YouTube for posterity. So with that, I am going to give the floor to Tom, and Tom, why don't you take us through it?
Okay, thank you, Leif, and thank you for the music too. Excellent choice. So, here, there you go. Okay, can everyone see my screen? Yes, thumbs up. Yeah. Okay. Okay, so thank you, Leif, Uri, and see. Okay, so thank you for Leif, Uri, and Joe for organizing this and for inviting me. Thank you for the panelists for joining, and for everyone for tuning in. So this work that I'm going to present is joint work with Hee-Young Yoon, who's one of the panelists, and she's a wonderful doctoral student at NYU, and she's much more knowledgeable about this research actually than I am, so I'm really counting on her to help me with the questions as well. So the research is really about consumption amount, but about how much we consume. So how we predict that and how much we actually consume. And specifically how that is influenced by how much you like what you are consuming. So there's quite some research on predicting how much we will like something. Right? So this is part of effective forecasting, and it's obviously relevant, right? It's obviously important. If I'm going to be choosing between TV shows to watch on Netflix, I'm going to predict how much I'm going to enjoy one show versus another, and I may pick the one that I think I will enjoy the most. Right? So my predictions of enjoyment are going to drive my choice. Now, so what we're looking at is not that, but is at predicting how much you'll consume, which is much less studied. So let's say that I'm going to be binge watching a TV show. Question is exactly how many episodes am I going to watch? What's my prediction, and how many do I actually watch? So that's kind of the general context. So there's a lot of research already about effective forecasting, predicting how much we'll like something, not much on predicting how much we'll consume. Now, these two seem related, right? If I'm going to be predicting how much I consume should probably depend on how much I like something, right? If I like it more, I'm going to consume more. And that's obviously true, right? It has to be true, especially for large differences in liking. So if there's a TV show that I love, another TV show that I really like, or another TV show, let's say, that I find boring, I'm going to watch more episodes of a TV show that I love than one that I find boring. That makes perfect sense. But the question is, what if the differences in liking are smaller? These are both good things. These are both things you like, but one you like more than the other. Does that still matter for how much you consume? So just a quick example here. So let's say you get an offer for a discount, 50% off, buying episodes of How I Met Your Mother. It's a TV show, and let's say you love that TV show, but there's 10 seasons of it. So there's more than 100 episodes. So the question is like, how many episodes should you buy with this offer? It kind of depends on how many that you think you will watch. Now compare that to, you get an offer for another TV show instead, Two Broke Girls. So that's a show that you like as well, but you don't love. Right? And the question is, how many do you think you will watch of that show? Is it the same as the first one? Or is it different? Now, that's all about TV shows, and actually we're not going to do anything with TV shows. So I'm going to give you another example that's more closer to what we're actually doing in the studies, which is with food. So let's say that you go up to a fruit stand. I think they're still operational, so you go to an outdoor fruit stand, and you want to buy strawberries. Now, it turns out that the strawberries that they have are your favorite strawberries, ones you really love. These are Belgian strawberries. So you really like Belgian strawberries, and they happen to have those, and you have to figure out, okay, how many am I going to buy of them? Well, it depends on how many you think you're going to eat. Now, let's say instead of Belgian strawberries, they have California strawberries. Now, California strawberries you like too, but you don't like them as much as Belgian strawberries. So how many of those do you think you will eat, and how many would you buy? Right? So that's the question we're looking at. So the first part of the question is, what people predict. Do they predict that these small differences in liking between a Belgian strawberry and a California strawberry will affect how many they'll eat? And the second part is what actually happens. Do you actually consume more Belgian strawberries than California strawberries? And if you put that together, it means, does liking, the difference in liking, the difference between a California and a Belgian strawberry, affect consumption amount as much as you think it will? That's really the basic question, the interaction of these two. Our prediction is that people tend to overestimate how much these differences in liking are going to affect how much they consume. Right? People think that they will eat more of the Belgian strawberry than the California one, even though in reality the difference is much smaller. Another way to think about that is that our actual consumption behavior, it's not as discerning as we think. Right? We're not as sensitive to these differences. So why do we think that? Well, if you think about actual consumption quantity, it's driven by a lot of different factors, right? So one of them is going to be liking, how much you like whatever you consume. But there's lots of other ones. There's changes in liking over time, adaptation, sensitization, needs, undifferentiated needs like hunger, boredom, need to be entertained, consumption opportunities. Do you have time to eat? Do you have time to watch TV? Available alternatives, are there other things you can eat? Is it top of mind? Do I remember that I have these strawberries in the fridge? Habits, and lots of other things, right? So there's a lot of factors that drive consumption amount, and many of those do not depend on liking or undifferentiating. So that's actual consumption, what we think actual consumption. So what about predictions? I think with predictions, people will focus more on liking and ignore or underweight these other drivers of consumption, all these other things that are going on. And there are several reasons for that. The first one is, you know liking, you know what you like, or at least we think we know what we like. And we also feel like it doesn't change. And so it may change, but it's not what we feel. Right? So if you think about, strawberries, I know how much I like strawberries. I know how much I like this TV show. So it's known. Second is, so if compared to some of these other factors, like for instance, boredom, I don't know exactly how bored I will be later. I don't know how top of mind these strawberries are going to be. That's less known than my liking of the strawberries. Right? Rely more on some stuff that I know. It's also salient, especially in a shopping situation, right? So when you're shopping, you're looking at options. This is the first thing that jumps out of you. It's like, how much do I like this? Right? It's an immediate automatic response that you'll have to whatever it is you're looking at. Very much more so than all these other factors like boredom, top of mind. And it also seems normative. It seems appropriate. It seems rational to consume more of something that you like more. And so we also know that when people make predictions, these predictions tend to be more normative than the actual behavior. So that would be part of it as well. So it's We know liking, we know what we like. It's very salient when we make decisions. And it seems the appropriate thing to rely on. I think all these may matter. Okay, so that's our perspective, but there's a lot of other work that is very much related to this in lots of different areas that I think is consistent with our predictions. So one area is this work on mindlessness of consumption. Right? The idea that a lot of consumption, especially food, is rather mindless. And so this will be consistent with the idea that it's not as influenced, not as discerning, not as influenced by quality or by our liking as we think, right? Because it's mindless. And so it is possible that people also underestimate the mindlessness of their consumption. And if they underestimate the mindlessness of their consumption, they should overestimate the impact of life. So that's going to be consistent with some of our studies, but some studies, actually there the consumption is not that mindless. It's going to be a little bit more mindful. There's also an old literature, a very well established literature on the relationship between attitudes and behavior. And this idea that our attitudes are not that predictive of our behavior. So many times our behavior deviates from our attitude. And so this would be a very specific example of that, what we're looking at. And then there is the work by Kahneman and Tversky on representativeness heuristic and attribute substitution that I think is also consistent. And so the idea that when you're predicting an outcome, many people, instead of actually predicting the outcome, they are evaluating the input, right? And they just provide that response, or they translate that response without taking into account that the relationship between the input and the outcome is not perfect. And so it should be, their answer should be regressive, but it's not sufficiently regressive. So in this case, what that would mean is that when you're predicting how much you consume, instead of doing that, what you're really doing is you're kind of evaluating how much you like this product, right? How much you like this TV show, how much you like the strawberry. And you just immediately translate that. And so that's...
Sorry, just brief interruption. A couple of sort of related questions from the audience are basically asking some form of, is there something special about liking here? Or is it just generally that it's focusing on some attribute? So liking is something they focus on, and they focus on it a lot in prospect, but in consumption, it's less focal. And that could be true of any other dimension? Or is there something special about liking that is unique in this context?
Yeah, so I would say that there's something special about liking. Definitely there are, you can make anything salient and that will have more impact, right? You can make everything more known. So that's true for any attribute. But this is more true, I think, for liking than for other ones. And actually, this is also where we kind of deviate a little bit from this work by Kahneman and Tversky, where if you think about, like, what they are saying is that if you look at their studies in representative heuristics, right? So they can provide people one piece of information, let's say something about intelligence, and then you have to predict the GPA, right? And so people focus on this one piece of information and they don't regress enough. Now, in our situation, people can have multiple pieces of information, right? So when you're predicting how much you will consume of something, each of something during an hour, you have, how much you like this, but you also have other information like, how hungry you are and how long an hour is and things like that, right? And what you're going to be doing during that hour. This is all information you have. And so part of what we're saying is not just that you're focusing on the information you have, which is true, but also that you're specifically going to focus on liking rather than other parts of input. And the reason why you will do that is because of these three things I mentioned before, because liking, we think, is more salient, is more, you feel you know it more, and also seems more appropriate, seems more right, more normative to kind of consume more when you like something.
Tom, can I follow up on, go ahead, Rebecca.
Yeah, just a question. I don't know if you're going to get to this, but how does your theorizing kind of relate to Itamar Simonson's results about, people when they're choosing in advance a set of options, incorporate more variety than they end up kind of wanting when they're actually choosing on each occasion. It seems, at least on the surface of it, kind of contrary to your prediction.
Yeah, so we have a study that I'm not presenting now, where we actually find the opposite of that, where people actually think that they will. Okay, I'm going to very quickly describe it. There's two bowls of jelly beans, one you like more and one you like less, and we ask people like, how many are you going to consume of each bowl, right? And people say that they will consume much more of the ones that they like more than the one they like less. Whereas in reality, if you look at actual consumption, people switch back and forth much more. So that suggests that actually people engage in more variety seeking and they eat more of the less preferred jelly bean than they were predicting. Now, that is a very different setup than Itamar's, right? Where there's time passing in between,
right?
Mm-hmm. So I think people actually do seek a lot of variety and often go to things that are, as you know, like things that they like less to improve variety when it's all happening at the same time, right?
Right.
So when there's more time in between. And there's more time in between, then people do overestimate the need for variety because they probably engage in time contraction and they overestimate satiation.
Okay. You should always answer Rebecca's question with jelly beans. That's a good call.
Yes, exactly. I know. Well, I have a lot of jelly beans.
So I have a quick question related to the first one. When you say overestimate the effect of liking, you're essentially saying you're underestimating the effect of a whole bunch of contextual variables. Yeah. So is it fair to me, not surprisingly, to think of this as some differential discounting model in which I just don't appreciate the effect of context on my future behavior, and therefore you will observe that I'm over-relying on.
Yes, that's definitely, yeah. So it's definitely that people don't appreciate the effect of context, right? So behavior is a lot more contextualized than we realize, and that's definitely part of it, right? And towards the end, I'll kind of get a little bit of debiasing, and we find that sometimes highlighting the context helps, and sometimes it doesn't. But in general, I think, yes, that's part of what's going on. People don't think about these other contextual variables that are not salient, that are not known, that are not as normative.
Super quickly, Romain and Carrie have a paper that looks at variety by the meal. And so breakfast, people eat the same thing every day, and then dinner, they eat different things every day. So yogurt jelly beans might just be on the continuum of breakfast to dinner or dessert or something. Yeah. So it might even be the feature of the food itself. It could be the difference.
Yes, yeah. So we didn't really, we stuck a lot to jelly beans, so we didn't really vary that a lot, but that may matter. Yeah, I agree. Okay.
Can I ask one question? Another thing that came to mind was, I don't think it's inconsistent, but the idea was that people are mistaking the differences within category for the differences between categories. So that, like, the reason I'm at a fruit stand is because I like fruit. I'm not at is there a meat stand? I'm not sure the opposite is. I'm not at a meat stand because I like fruit. And so I'm focused on the differences within the category instead of realizing that the reason I'm looking at strawberries at all is because I really like strawberries or fruit or whatever the higher category is.
Yeah, I think that's definitely part of what's going on, right? So where, like the first study, you'll see like, two types of jelly beans, and then, if you have two types, you kind of look at the differences between these types, and you forget that all jelly beans are really just sugar, and they all taste kind of similar, and they're pretty good and pretty tasty, right? I think that's part of it. But you'll see there's other studies where we kind of try to downplay that a little bit, and the effect persists. But yeah, I think that definitely adds to it. Yeah. Okay. So, okay. So that's our general thinking, and it's consistent with a lot of prior research. There's a lot of other processes that feed into it, I think. Why does it matter? Why does it matter that people get this wrong, how much they'll consume? Well, Most obvious reason is for inventory, right? You get inventory problems. You may buy too many Belgian strawberries, not enough California strawberries. So that's a problem. But it may also be problematic for strategic decisions. So let's say that you're trying to increase your consumption of a particular good. For instance, I want to consume more water, right? So I want to drink more water during the day. Well, if I believe that if I have fancy water that I really like, I will drink more, then I'm going to start buying a lot of Fiji water and carrying that around and hoping that I will drink more water. If in reality you would drink just as much of Poland Spring, then actually you're wasting money, right? So that's one way to look at it. Personally, what resonates with me the most is kind of the opposite, where you're trying to decrease a certain type of consumption. You say, well, if I want to consume less of this, maybe I'll reduce the quality and I will consume less. So this is what I did during my PhD years in Florida. I canceled my premium cable subscription, assuming that I'm going to watch fewer TV shows if the TV shows that I can watch are worse. And of course, what happened was that I watched the same amount of TV shows, I just watched worse shows. Right? And so that's, anecdotal evidence, but now let's look at it in a little bit more systematic way. So here's the first study, a very simple study with jelly beans. So we have a small sample, 59 NYU undergraduate students came to the lab. Most of our studies in the lab because we need to kind of be there and make sure that they behave the way they're supposed to. So 59 NYU undergraduates, we divide them in two groups between subjects. So one group gets the less preferred jelly bean and one group is gonna get more preferred jelly beans. And they're gonna predict how many they will eat during the entire session. So they start at the start of the session, 1 hour session. And at the end, we observe how many they actually eat. Right? That's it, very simple. So everybody makes a prediction and then eats. And some get more preferred, some get less preferred. How does that work? Well, everybody gets 2 jelly beans to begin with, 1 cotton candy and 1 what's called a very cherry jelly bean. They're good jelly beans. People tend to like those, but people do have some preferences. They like one more than the other, and it differs between people. So they taste them, and then they say how much they like each one. And they also say which flavor they like better. And so going back to Mike's points, like this kind of setup definitely highlights the difference between the jelly beans, right? Between jelly beans rather than jelly beans versus other foods. So they do that, and then they predict. We tell them like, look, you're gonna get a bowl of 1 set of jelly beans. We're gonna do a coin flip, and based on that coin flip, you're gonna get a bowl to eat during the rest of the session, right? And so we ask them, if you get the cotton candy, how many would you eat? And if you get the very cherry, 50 of those, how many would you eat? Right? They make predictions for both in this case. And then there's a coin flip, an actual coin flip experimenter does that. They get a bowl of jelly beans that corresponds with the coin flip, cotton candy or cherry. And then we just observe them eating it during the rest of the session, 60 minutes. What happens during the rest of the session is kind of out of our control. These are mostly other researchers doing studies, and so that can be more or less engaging. And participants, of course, don't know this in advance, so it's pretty hard to predict exactly how many. So that's the setup. Okay, so what happens if we just look at prediction? People predict that they will eat more of the jelly beans that they like more. That's surprising. And then when I look at behavior, how many do people actually eat? Well, they actually eat slightly more if they get the less preferred jelly beans. So we see this several times that you actually get a slightly higher consumption of the less preferred one. It's never reliable, which is kind of unfortunate because I have this intuition that there must be situations in which people actually consume more of something they like less to get to the same utility level. But we haven't identified, we haven't found any situation like that. Sometimes it hints at it, but it's never been the case. But I'll get back to that later. Okay, so here, very simple. People predicted that I would eat more of the one they prefer more, but if they got the one that they preferred less, they ate about the same amount. Right? So the behavior was less discerning than their predictions. Now, of course,
Tom?
in this case, sorry, yeah.
Sorry, just a small question about that. So would have thought that it's pretty hard to predict jelly bean consumption in general. Like I have no idea how many jelly beans I have in a sitting. How good are they overall? So not the conditional effects, but the correlation simply between their predictions and their final consumption. Do people who think they're going to have a lot of jelly beans have more than people who think they're going to have very few, for example?
I think they're pretty good, but I'm going to let Hyung answer that because I think Hyung knows this much better than I do. He knows the actual data.
Yeah, so I remember we did look at the correlation between the two, and it was pretty correlated. It was significantly correlated. So it was not like random guess and consumption.
So yeah, that's what I remember too, is that they're pretty good at it. I mean, not in an absolute sense, but people say they will eat more, tend to eat more.
And part of the reason why that's interesting is it suggests that they're not just noisy forecasters, they're good forecasters. They're just bad at forecasting the influence of liking.
Yeah.
Is that approximately right?
Exactly.
And
yeah, I mean, of course, the average predictions are often pretty close to the average behavior, but of course, there's a lot of noise there. But in general, also the people who say they will eat more also tend to eat more. But they're not terrible. They're not terrible.
Tom, along a similar line, is it the case that people are more accurate consistently when they're making forecasts for their preferred thing, but they're wildly inaccurate for the less preferred, suggesting there's value in choosing your preferred food because you get it right how much you consume?
We think that that's usually the pattern, right? So where they mostly underestimate how many they will consume of the less preferred one, right? How many you will consume of something that's not that great. And most studies, the action seems to be more there with the less preferred than the more preferred, but it's not always the case.
Yeah.
And we're kind of hesitant at making those simple comparisons because they can be due to lots of different reasons, right? So they don't know exactly what's going to happen in that 1 hour. And so if it happens to be much more engaging than they thought, then maybe they'll consume a lot less. And so there's these shocks that they can't really predict. So that's why we focus mostly on the interaction, because we can't really look at that simple effect. But if we were to look at it most of the time, yes, most of the action is in the less preferred one. But they underestimate how many.
Yeah. And Tom, in this and other studies, when you just look at the within subject delta between the predicted and the actual, is it the bunch, or do you have some people who are just wildly off and some that are fairly accurate, under, over?
I know. I think. I mean, I think it's fairly normally distributed as far as I remember. Hyung, do you?
Yeah, it's pretty distributed. I just look at the distribution of the jelly bean they consume in study 1. We do see a lot of 0 and like 15 and 30, but the standard deviation is pretty high.
And the differences are also,
Yeah.
It's not like one person says 50 and consumes 0. That seems to be very rare.
Yeah.
Okay. So now there's a lot of issues with these studies. So in this case, we do make liking very salient. People rate how much they like it before they say how much they will consume. There's 2 different jelly beans that differ in liking. So there's this joint evaluation situation at prediction, whereas when they're actually consuming, they only have 1 type of jelly bean. Right? So that may also kind of contribute to the fact that liking has more impact on prediction than on behavior, because at time of prediction is joint and then it becomes separate, even though people still remember that there was another jelly bean as well.
Tom, just quickly,
yeah.
that's a bit relates to my silly fruit stand thing, but I wasn't saying that as like a confound, but as that's life. Like we're constantly putting ourselves in the self-selected thing where we're in on the strawberry thing instead of doing the other thing. And here as well, we're like, maybe it's a confound, but also we're always doing joint and then separate, right? So it's the life condition,
Yeah, so life has confounds, right? So like where that, it's true that when you're shopping, and this I think is also Krishi's points when he talks about, separate joint consumption. Like when you're shopping, in many cases, you're in a joint evaluation situation, right? Do I buy brand A or do I buy brand B? Whereas in consumption, you're often in these separate evaluation. And I think that adds to it. But it's not essential for our effect, as I'll see in the next study. So in the next study, what we're trying to do is, instead of having joint evaluation with prediction and separate evaluation with consumption, we're going to do both separate. And so now everybody's situation, every participant's situation will only be like one set of stimuli. Same. And we're going to also do it not with food, but with comics, like little comics that you see in the.
Tom, do you also do versions of this where both the predictions and the consumption are joint?
Yes, that's the study that I was talking about earlier with the 2 bowls of jelly beans. Like, so they make predictions for both, and then they can consume both.
Ah, they do get both.
And so we still get the effects, but it's smaller, right? Because now they can just consume the good ones if they wanted to. Right? But they still consume some of the less preferred ones and more so than they expect. Yeah. So, but I'm not showing this one. Okay, so in this study, this with comics. So there's now a set of comics that is more funny, one that is less funny. And some people get assigned to one set, some people get assigned to the other set, but they don't know that the other set exists. Right? So it's kind of separate. So we do this also in the lab with NYU undergraduates. And just explaining how we get these comics. So we had pre-tested a set of 240 comics. So these are like 1-cell comics. Now, some of them are more funny, some of them are less funny. So we pre-test them with M-Turkers. And the top 80 ones, the ones that are seen as most funny, are taken as the funny comics, the funny sets. And the middle 80 ones are the less funny ones. So the less funny ones, they're not painful. They're just, at worst, they're boring, right? And so that's the difference. And we also do this by gender because it turns out there's a lot of gender difference. First, we assign people either to the more funny or the less funny sets. But of course, it's important they don't know what kind of set they have, and they also don't know there's another set that exists. So we just tell them, we have a set of 80 comics, and you can request seeing comics, and you have to kind of predict how many that you want to watch. That's it. They don't know if they're more or less funny. Now, to give them an idea of what's in the set, what we do is we show everybody 5 randomly selected comics from the set. And these are independently drawn for each subject separately. Right? So they get an idea of what these comics are like. They don't rate them or anything like that, but they get an idea. And to get a comic, they don't just have to click on it, but they have to enter a verification code, like a CAPTCHA. Right? So there's a small cost, non-monetary cost to getting comics. If we wouldn't impose that cost, they could just say just give me all the comics, and they just click through it. Right? And so we need to have some kind of cost. But they're also familiar with the cost because in the sample, to get a sample of the 5 comics, they also have to every time enter the CAPTCHA. They know exactly what's happening. They have a sample of 5 comics, and they have to enter the CAPTCHA each time. And so important, they don't know there's another set as well. It's all separate. And then they make a prediction. Given that these are the comics, how many of those do you think you will view in the next 5 minutes? Now, if they don't get a comic, then they can't do anything. So that's why we need to do this in the lab, right? So they can't look on their phone, can't do anything else. They can look at the ceiling and they can look at a blank screen, that's it. And they know that, so they have to request a certain number of comics. And then we just watch how many of comics they view during these 5 minutes. Right? Each time they have to enter that CAPTCHA. So that's the setup. Here are the results. First, what do they predict? Again, people don't know that there's a funny and non-funny set of comics. They just happen to be in one set. Those who happen to get the funnier sets do think that they will view more than those who get the less funny sets. So they evaluate them before, but they still use that sense. And actual behavior is completely flat. It doesn't really matter how funny the comics are. They end up consuming the same amount, or requesting the same amount during that 5-minute period. So it seems to also extend to situations that are not with foods and where you cannot compare the more and less liked options in prediction. Okay, so it's still a pretty weird setup, especially with the comics, I think, because what happens here is that if you don't have comics, you're just staring at a blank screen, right? So there's no alternative that you can consume. And so you could imagine that, if there's an alternative that you can consume, you can do something else, then maybe, the quality, the liking will really start to matter, because you're only going to consume the good ones, because if you can consume something else, why would you consume the bad one? So we're going to do that again with comics, and this time we're going to give everybody also a set of paintings that they can look at. So they can look at comics or they can look at paintings. They also have to enter the caption, right? So every time they can decide what they want to look at. These are some images of the paintings, mostly abstract, expressionist. And this is actually what they saw. So this is a framework that they see, right? So they can click on a comic and request that, or they can click on a painting and request that every time. And this is for 4 minutes. So, and they know this is happening, right? So they know what the paintings are like. They know that they can also get paintings. Does that change the predictions? The predictions don't change. They still think that they will get more when they get the funnier comics than when they get the less funny comics. Does behavior become more sensitive to quality? It does. It does a little bit, but not fully, right? So what you see here is that now there is a difference where people consume more of the funnier ones and the less funny ones, and all of them go down quite a lot because now they're paintings and apparently they don't fully appreciate that. But it's a significant reduction. So how funny the comics are does matter for behavior now, but it matters more for prediction. Right? That's generally what we see with the comics. We tried the same thing with the jelly beans as well, to give them something else to eat. So in addition to kind of giving them something else to eat, in this case a bowl of M&Ms, we also want to see if the effect also holds when we make the liking less obvious, when we make the liking less explicit before they rate their predictions. Right? So in this case, what we're going to do is simply first have them give their predictions and then say how much they like each jelly bean. Right? So the idea that predictions don't immediately follow liking, and reduce some of these possible demand effects. So everybody gets a bowl of jelly beans, either more or less preferred, but they also get a bowl of M&Ms, and they know that. They taste cotton candy and a cherry jelly bean, and then they make a prediction. So they don't say how much they like it. They just taste each one, and they say how many of these would you eat? How many of those would you eat? So it's still like, we can still compare it, but they don't explicitly rate the liking. But we assume that they automatically, elicit a liking of how much they like the taste, and that they use that information to make the prediction. After they make the prediction, they indicate how much they like each, and which one they like, and which one they prefer, because we need to have that information. Then we flip a coin, and they either get cotton candy or cherry, and a bowl of M&Ms. And then we see how much they consume. Right. So what we see here is, again, in the prediction, now they know they also have a bowl of M&Ms. Same idea, they think that they will consume a lot more of the one that they like more, even though they provide predictions before liking. Almost twice as many. So it's a big difference in prediction. What about behavior? Does behavior become more sensitive to liking now that they have an alternative option? They don't have to eat the ones they don't like as much? No, that's just flat. Right? So it seems like the effect just persists in this case. Even when there's an outside option, it doesn't even weaken.
Tom, I had a question. So I'm wondering if part of what's going on here is that in everyday life, the decision of how much to consume is kind of a two-stage decision, right? I decide what to take out of the cabinet or the fridge, and then I take with me where I'm going to go consume, and then I've reduced my options down to one thing. And so I'm wondering if part of what's going on is that people's choices right, when doing that first stage screening are more sensitive to liking. And they're not that often in the situation where they're kind of, you know, have a bowl of their less preferred option in front of them, because whatever they're feeling like at the moment is what they take with them, right? And so they're kind of missing experience with that cell and kind of conflate the impact of liking on choice for the impact of liking on amount of consumption.
Yeah, I think that's true, right? So and that definitely matters, right? So I think there are quite some situations where you know, so you're standing in the store and you have different options, and you have to decide at the same time, what am I going to buy and how many am I going to buy of it, right? It's kind of like, right, these two decisions are very close together. And there's also situations like, and I think that's when having these other ones out there, these other options out there, definitely magnifies the effect, the impact of liking. But as you see with this comic study, I mean, it's also the case when you just have one set and you don't see the alternative, that you're still kind of influenced by how much you like that one set. And it still drives how many you think you will consume, even in the absence of the alternative. But having the alternative there definitely magnifies the effect. And there's a lot of situations in the real world, like Mike said, like where that is the case, where we have the alternative there when we make these decisions, but not always, of course. And especially if you're going to start separating that, first you kind of can really kind of make it so that first you have to make your decision, and you have to commit to that, and then we're going to ask you like how many will you eat of those. It would be kind of interesting to see if that by itself just weakens the effect, right? So if you can see a situation where you choose between two, then the next stage you have to say, okay, now you've chosen, how many would you consume of those, to see if that actually they drop the liking from their decision. A little bit like a screening effect, right? So I've already used that information, and now I kind of drop that information. But it can also be the opposite, where because you've used it, you're sensitized to it and it's salient, and you use it even more. I don't know. But that's not something we did, but that would be interesting to kind of try to play with separating the decision to choose from the decision about how many to consume.
Tom, this is part clarification. So in the prediction, did they know that M&Ms are available?
Yes, they did, yeah.
Okay, so this is prediction while knowing M&Ms. Yeah. So now you can think of it as a misprediction on M&Ms, right? Because your actual behavior in relationship to liking of the jelly beans is regressive, essentially. The high liking goes down, and maybe not significant, but that's the direction. So is the action of us not knowing how to balance the focal versus the outside options that here?
Yeah, I don't know. Hyung, do you know how, like, if there's a difference in how many M&Ms they ate? I know in the previous one, so they also knew how many paintings that they were. If you go back a little bit, these are the paintings, right? They knew how many paintings they were, but they didn't really seem to take that into account. And the weird thing is here with behavior, you see a difference in how many good and bad comics they actually consumed, but they looked at the exact same number of paintings.
Yeah.
That's kind of weird.
And also there was no difference between the number of M&Ms they consumed between condition, and nor how much they liked M&Ms between condition. And when we adjust it for those variables, like result doesn't change too.
Yeah. So if you also look here, these predictions are really not that different that they were before without M&Ms. So it's, I mean, of course, I'm comparing different groups of people, but it seems that they don't really take it that much into account, and that's ridiculous. Okay, so the next study is actually one that was suggested by Joe Simmons. So thank you, Joe. This was in the Choice Symposium. So one issue is that with our predictions, what we see is that people kind of tell us that they will consume more of the one they like more, right? And they may honestly believe that, but it may also be the case that is self-presentation, that people feel like, oh, I should say that I consume more of the one I like more. That seems to be the right thing to say. I don't necessarily believe that, but that's what I'm going to say. So it's kind of a self-reporting thing, a self-presentation problem. So one way to get around that may be to get a different set of participants and have them guess the consumption of the original participants and incentivize them to guess correctly. So that's kind of what we did. So we took another set of NYU undergraduates from the same pool as the first study, and we asked them to guess the consumption of people in the first study. We explained the entire situation to them. The best guesses get $50. And just kind of to remind you, this is the first study. This is the behavior of people in the first study, where it was essentially flat. They consumed as many of the more preferred and less preferred jelly beans. And so we asked them to predict the consumption of these people. We described the entire study. They also get the 2 jelly beans. So they know exactly what they taste like. And so they're well calibrated in terms of what the difference in taste is. That's important. And then they just guess. And we incentivize them to guess correctly. And so how many do you think people in this condition consumed? And how do you think people in this condition? And so those are their guesses. So they're still, using it just as much as the predictors were before. It doesn't seem to be an issue of self-presentation. People seem to honestly believe that they will consume more of the better jelly beans, even if you incentivize them. Okay, so thank you, Joe. Then we wanted to look a little bit at normative implications. Can this prediction error lead to suboptimal decisions as judged by participants themselves? So again, we took people to the lab, we showed them the comics, but now we show them actually both set of comics just to have a strong manipulation. So they, of course, we don't tell them one is funny and one is not. We say there's set A and set B. We show you 5 from set A, we show you 5 from set B. So they know that, they get some idea. And then we ask them to pre-commit. So it's not just a prediction, they really have to commit, they have to say how many of these comics they want to purchase. We tell them, look, you're going to get either set A or set B. You have some idea what they like, you sampled. If you get set A, how many do you want to purchase? If you get set B, how many do you want to purchase to consume during the next 4 minutes? What is purchasing? Purchasing just means that you have to enter a verification code for each comic, which is 6 digits. And different from before, you have to decide on this in advance. So if I say, I want to get 20 comics if I get set A, then you're going to have to enter 20 of these CAPTCHAs, regardless of how many you consume. Right? And you can't get more afterwards. Right? You pre-committed to 20. So that's the setup. You have to decide in advance how many you want to purchase. Okay, so and then we flip a coin. They either get set A or set B, and then we observe how many they actually watch. But that's not very interesting here because they already pre-committed to it. So they paid for it in advance, and they can't watch more than that they paid for. Right, so behavior is not so interesting. The interesting thing is the next question, which is why we asked them to evaluate their decision afterwards. Should they have purchased more or fewer comics in hindsight? And so we think that they are more likely to say that they should have purchased more if they get the less funny comics. Right? That they feel like they under-purchased the less funny comics. We also measure their enjoyment of the comic. So one problem is, one explanation for all these effects really is that instead of liking mattering less than we think matters, it could be that liking changes. That in the beginning, there's a big difference between these two sets, these two options, but then over time, they become more similar. And so that's why we consume the same, and we don't anticipate that. So to check whether maybe the funny ones became less funny, and it turns out that the bad comics actually were better than expected, we ask this question at the end, where we ask them to compare the comics they got to the ones they had in the sample. Okay, and we actually have done this in other studies as well, but I'm just going to show you this result in this study. Okay, so first predictions, and these are not really predictions, right? This is commitment. This is how many they purchase in advance. So they purchase more of the one that they like more. So they say, like, if I get this set, this good set, I want more. If I get this set, I want fewer. Behavior now is exactly the same because they're pre-committed, right? So they can't go higher than what they purchased, and there's no cost to clicking on it because they've already paid for it. Right? So that makes sense. Just the main effect of how funny the comics are. More interesting, the evaluation of their decision afterwards. And so they've done all this, and we ask them, should you have purchased more comics or fewer? What you see is that in general, people think that they should have purchased more. Everybody thinks like, no, I should have purchased more comics. Maybe people don't know what 4 minutes is, or they have a hard time, anticipating that, but that seems to be the case. The more interesting point is that this is more so when they got the less preferred comics. Right? So when they got the less preferred comics, they're more likely to say like, oh, I should have purchased more. So they're more likely to say they under-purchased when they got the less preferred one than when they got the more preferred. And then if you look at actual enjoyment, it kind of goes the opposite to this idea that they become closer together. At least in these self-reports, they say, well, the more preferred set was even better than what I anticipated, and the less preferred set was even worse than what I anticipated. I'm not sure what you can infer from that necessarily, but it's definitely not in the direction that they came closer together. That doesn't seem to be. Okay, so just gonna quickly just mention that we did this also with something with a durable good outside the lab. This was with lip balm. I'm just gonna quickly go through this. So what we found there is that when we give people either better lip balm or worse lip balm, they think that they will use it more when they get the better lip balm, but behavior is pretty similar, although it was not a reliable effect. This is, I think, what Leif likes to call a poor man's interaction. So you have a significant effect that becomes non-significant, but the change is not significant. But there's some indication, not very strong, but some indication that this also applies to durable things, how much you use a lip balm outside of the lab. Okay, so what's going on? I mentioned this in the beginning, we think people focus on liking because it's salient, it's known, it's normative, all these things. And they don't adjust enough for all these contextual factors, right? Like boredom, hunger, usage opportunities. And they differ probably between studies. If that's the case, then if we would make one of these salient, then maybe they get better. Maybe they become more regressive. We tried that with the comics, where we have people make a prediction. So how many of these would you watch? And for half of the people, before they make a prediction, we remind them that it's going to be boring. So how bored do you think you would feel if you just stare at a monitor for 4 minutes without watching comics? And so we just remind them of boredom. Maybe that helps. So here's what happens without the boredom reminder. People think they will watch more when they get the better set than the worse set. If you remind them of boredom, does it attenuate? Well, actually it reverses, which we didn't expect. So now they say, oh, we're going to watch more of the worst comics. And so this is in line with my intuition I had initially, and maybe they share that intuition, that, if I'm really going to be bored, I need more bad comics to be entertained than I need good comics. Right? I need a greater number of comics to get the same amount of entertainment to kind of get away from the boredom. At least, that's just speculation, but that seems to be consistent. But it's a significant reversal, which we didn't expect. We also tried to say, like, oh, what if we just make people feel bored? We'll use that boredom. So we tried that as well, where half the people we kind of make feel bored. Everybody, before they make a prediction, there's a loading page. And either it's just 1 second, so that's not boring, or there's like a 30-second wait, so that's boring. So they have a feeling of boredom by the time they have to make that prediction. Does that matter? Does that help? This is without boredom. This is with feeling boredom. No, it doesn't help. It doesn't really matter. So feeling bored doesn't help. Reminding people of boredom helps, but just feeling bored doesn't help. They don't automatically take it into account. You see that people did feel bored, but they did not consider it more. So just feeling is not enough to consider. Then we tried, and this is the final thing I'll show, then we tried to do it with jelly beans as well. And we have many studies, but in a nutshell, what happened there is that it didn't work. We couldn't debias the jelly bean studies. So we did, now we've got 10 studies, and none of those showed reliable debiasing. So just give you one example. So this is one with 400 mTurkers. This is just prediction, so we can do it on mTurk with a decent sample size. So people predict how many jelly beans they will eat, better ones or the worst ones. And for half of them, before they do that, we kind of remind them of, like, how important is taste for this, but also how important is hunger, how engaged you are, boredom, health concerns, sugar craving, all those things that all come from things that I've mentioned before in a study. And so what we find is that, don't remind them, you see the effect, remind them, it's still there, it's even slightly stronger. So they didn't debias them at all, like hitting them over the head and talking about it. And then we got to think, well, why is that happening? Well, if you go back to the boredom reminder where it reversed, in reality, we didn't really debias them. We didn't get them to not use liking. They just used liking in a different way. Right? We activated a lay belief that the ones that you like more, you may need less of. Right? And so maybe this is what we should do with jelly beans. And this is what we're going to do next, is try to see if we can maybe let them think about savoring. Right? And savoring is something that may also interact with liking. But so far, it seems it's very hard to get people to not use liking. But we can get them to use it in different ways, perhaps. So that's what I have. I've got 1 minute left. Any last questions?
I had a question. So I wondered, as you're talking about all this debiasing stuff, whether you've done this kind of study with 2 rounds, right? So you have the study where you ask them, do you make a mistake? That suggests that you could then have them have a second round where they make the same decision again, and then see, do they actually change their strategy, ideally without prompting them to consider whether they made a mistake, right?
So we didn't do exactly that, but so we did one where we did one of the debiasing studies. We had a study where they had been eating jelly beans, and then afterwards we asked them to make predictions, right?
Right. So they were eating jelly beans for another study. Is that what you're talking about?
Yes.
Yeah, and the results were also not good. So we couldn't debias. Even when people have this experience of mindlessly eating in the lab, it didn't really help them accurately predicting how much they're going to consume.
Yeah, so these are people that had been eating jelly beans, not the exact same study, right? We didn't do the same study twice, but they had been eating jelly beans, and then as part of the debiasing manipulation, we had some people reminded of the jelly beans they had been eating and how many they had ate, and then make predictions, and they showed the same effects as the control. So that didn't really work. Now, if you make it very similar, I assume it will work, because there is some learning, it seems, right? So if you look at the comic study where we asked them afterwards, should you have purchased more or fewer comics? There, it seems people did learn, right? They do say, like, oh, I should have gotten more comics.
Right.
I don't think they learn a general rule, but they learn something.
Yeah, so
I do wonder if they would do that spontaneously, or if that's just because you prompted them to consider that.
Yeah, so we don't know. We don't know if they spontaneously would do it.
Yeah. So there was a question from audience asking like whether there was learning or not. So as far as I know, we don't have evidence saying that is learning or is no learning. But I remember that we asked how much they're going to consume after having eaten 30 jelly beans for 30 minutes. And if I remember correctly, I think we did see the pattern. The pattern got weaker. But I also think that if there's a learning, it would be very domain specific. So I don't think people will apply learning from like eating jelly bean to other domain like entertainment consumption.
Yeah.
But we haven't tested any of that yet.
Yeah. So similar to Rebecca's findings with Nathan, where like the learning is very domain specific.
Yeah.
I'm gonna cut off the dialogue for the time being and thank Tom and all of our panelists for joining us today, as well as all of our audience. Just as a reminder, this video will eventually be compiled and posted and linked to the Data Colada webpage. And we'll be back again next week. So thanks, everybody. Enjoy your weekend, and I'll see you in a week. Thanks, Tom.
Thank you. Thanks, everyone. See you.